All right, we are live. Thank you so much, Neelesh, for joining us today in the wonderful afternoon. Hopefully, you're having a wonderful Thursday.
Yeah, thanks for having me. This is fun.
Yeah, this is gonna be a lot of fun. I was really interested about your background because I saw just you just were so involved in so much data infrastructure throughout your career. So to me, it's like there's a lot of different kind of ways you can kind of interact with data engineering, and I think being like software engineer, data infra, is definitely an interesting space. Um, but before diving into that, I always like to ask, just to break the ice. What do you do basically when you're not doing data work?
Oh wow, that's it's a mixed thing these days. Like it's like reading. I started to read a lot, random tech books, non-tech books. I do write, so the Substack I open takes up a sizable amount of my free time. Mostly just like ruminating on ideas, just writing things, and it takes a sort of a series of back and forth to get one post out. But
Yeah.
that's sort of keeping me busy as a hobby. And otherwise, it's mostly like watching shows, Netflix, taking walks, and it's a mixed bag of everything. I would say there's no
Yeah.
particular mindset to do one or the other.
Yeah. Do you have? I'm just curious. Do you have a specific show you're enjoying on Netflix or other channel?
My wife and I just started the third season of Lock and Key, which is sort of a fantasy show that is like based on like magical keys. And it was fun. And the
Hmm.
most recent one we watched was Dark. It's a German show that involves time travel. So
Okay.
that was sort of mind bending to watch, but it was fun.
Okay, so I think there's a little bit of a theme there.
Yeah,
I was like, is it gonna be something techie? And it's like, no, it's gonna be.
there's
it's
enough
gonna.
tech in my daily life that I need a break from.
Yes. Speaking of that tech, how did you kind of get started in the data world?
So it's kind of unusual. I don't think I have a straightforward story to say, but it kind of started with my first job, which was mostly cloud era when I this was back in 2014. My background comes from like operating system cloud when I studied in grad school, and that's sort of where I was possibly headed in general. Like that was my thought process that this is cloud and like it's coming up as an industry. We'll explore that, and I would have ended up in IBM sort of infrastructure as a service group. But then Cloudera came in the picture, had an offer from them, and I moved over to the Bay Area. And that kind of shifted my trajectory and pushed me into this whole data space, if you will.
Hmm.
Um, Cloudera was a beast back then,
Yeah.
and somewhere it still is now, I would say. A lot of learning from that space, given the umpteen products that they had in terms of open source spread. And so there was a lot to grasp when you just joined and got a lot of the insights at like big data at scale, if you will,
Yeah.
like operationalizing big data, understanding how MapReduce works, Hadoop, HDFS, those kind of basic things, and sort of seen Spark creep up early 2015-ish when people were jumping over and trying those use cases. And this is Spark, which is very nascent back then. It was just
Hmm.
tiny, very little community adoption, but it grew to what we know today. And that sort of led me to Stitch Fix, which was about 2017, early 2017, and that's where I joined this team. Was sort of tasked at building data infrastructure for data scientists, and that was the bulk of my time career-wise speaking. That was like 5 years there,
Hmm.
building tooling that is more focused on making sure data scientists and like general data practitioners are more productive.
Hmm.
And so that's where our team's rationale lied, like with big data tooling like Spark and Presto and S3. How do we get that value and how do we make them productive? I think that was our whole goal as a team. Learned a lot there, and then now I'm at DBT where sort of I'm in this internal architecture group, which is basically tasked at scaling the architecture, looking forward a few years from now, how the business will adapt and how it will scale, and just general health of the code base and things like that. So it's a very different ball game for me. So a lot of learning, and I've been here just today's 4 months actually, and
Hmm.
so
Hmm.
a lot of
Congrats.
interesting things that I've learned. It's different from my previous job, but I kind of like it because there's a lot of area to cover
Yeah.
just from where I stand.
Yeah. Yeah. And you're coming from a time when like data infrastructure was so much harder to work with. Again, Cloudera was probably some of the original like data infrastructure that was meant to make Hadoop a little more manageable. So no, I can see that. I'm just because you've kind of gone, I think before joining DBT, you kind of went on a journey. I feel like I don't remember which post it was, but or that said how many interviews you went through, but you went through a lot. So I was curious, like, what do you recommend people kind of study these days, whether it's for the first job or kind of what are you seeing people kind of getting asked on these data interviews and software interviews?
I don't think I actually gave like a traditional like data engineer role. Like it's mostly roles that were very like software
Mm-hmm.
architecture, kind of a general software engineering principles role. But the focus was either the team was doing a data product or data platform, or the company itself was. In this case, like DBT, the role is not very like data platform building. It was more like general software building, architecture, best practices. So it's not a direct answer to like say like, okay, this is what data engineering, but in general, like best practices for like interviewing would be understanding like systems at scale, how do they perform, what are the sort of trade-offs that you would do, and sort of sharpening that skill. I think that's where the more challenging aspect lies, because when they hire you as an engineer, you need to build that trust based on what you know and
Mm-hmm.
what you can bring to the table. And so I think that comes from your experience and comes from like what you've experienced in like the previous role or even studied over. So some of mine, I didn't get direct experience a lot from what was like typically asked in the interview. So I had to read up and
Mm-hmm.
sort of orient my mind into understanding those things at scale. I read a lot of blogs, saw a lot of videos, and sort of put it down to my own thinking and sharpen that skill. Without that, it was hard to just break the barrier of tech interviews, I would say. Coding itself is a whole different challenge. You have lead code, non-lead code, that whole argument. But that is another aspect that people should pay attention, like writing good code, testability, making sure that it's debuggable, and
Mm-hmm.
having people just write readable code and solving business problems. I think that's where the companies are targeting and looking at candidates for. So sharpening those two higher level skills, and then if you're going above, let's say the senior level, you're looking at staff plus. You're looking at a bit more leadership aspect to it. So you're looking at how teams would rely on your judgment to make like large initiatives happen,
Mm-hmm.
building that trust across teams, making sure things get executed, and sort of the processes part of it. And that comes from like the more behavioral side of the questions that people can ask you, and like how would you resolve conflicts, how would you unblock teams, how would you mentor, those kinds of like leadership aspect questions. So I think that's where the three sort of pieces of interview I think would lie. And so sharpening those skills would be my advice to go, because every company kind of looks for different things, but in the general ballpark, they kind of fit into these three areas of
Yeah.
skills. And so, on a high level, I think that's where you should focus on if you're actually looking for a job. And then it comes to like specific roles, skills, like if you want like SQL, Python, whatever language specific, that's a different ballgame. Like you have to prepare that separately and make sure you are aware. But generically speaking, these are sort of the buckets I would place the interviews into.
Yeah. Yeah, yeah, and then like once you get like through the interview, you're currently I think staff. I know you're currently at a staff role, and I'm curious, like what do you feel like you've kind of done to kind of stand out skill wise? Like because obviously the interview is one skill set, sadly, and then the actual job is different. So I'm curious, like what skills you feel like helped you stand out.
With as you grow as an engineer, one thing that has sort of been the path that I've taken is like taking more responsibility. Like in
Mm-hmm.
Stitch Fix, I sort of started off junior and like sort of fairly early in the career because I had just 2 years of experience coming out of Cloudera. And jumping into that role, I sort of had like just Java and Scala barely experience and didn't know Python as well. So I learned Python on the job and even Scala to the fullest extent. And I think the growth aspect came from picking up more responsibilities and owning more business problems.
Mm-hmm.
And not just that, but also delivering it to the full extent. So if you take up a business problem, can you see it through to the execution of it and actual completion, so that you know it went through correctly? If it didn't go through correctly, what can you retrospect? And so those kind of lessons are what you can pick up on the job and grow as well. And that's where you shine. That's where you actually show your skill and your mettle, where you can actually show, okay, I'm capable of doing this. I'm capable of adding more responsibility to what I already have, and then learn from that and go forward, and then prove your quality to the team and say, okay, this person can execute it at this level. And then that's where you get the promotion, you get the actual sort of leveling up that you see that happens traditionally. So I think you have to come to a point where you have to operate at that level with the skill set that you have, or learn along the way, and then go forward and make your case. And each company goes to a different like promotional path, I would say. Convincing different leaders and different committees might be different, but in general, it's like, how much impact can you do that can not necessarily be like part of the org, but like even if it's cross-functional, because at a higher level you have to do cross-functional work and work with like different teams, different stakeholders, set expectations, and all of that. The whole life cycle of a software delivery is to play here. And so I think I went through a lot of that lessons. I learned from leaders. I learned from like folks who were fairly senior to me, and sort of took that and sort of grew slowly into the roles that I had. And then it ended up being like, do I have the skills to crack interviews that are at this level? And so that's the sort of previous discussion we had, which was, how do you actually get to a point where you prove your mettle outside and say, okay, I know these things. Can I prove it in the interview? And so that's where I think you can do your work.
Yeah, it kind of sucks that those are sometimes slightly different skills. Sadly, how you show that you've gotten this skill is different, which I've always found interesting. Because I'm like, I mean, more than likely, if you were a senior engineer at a decently tech-focused company, you can probably be a senior engineer at another one. But I also get that they have to be somewhat standard, so that they don't feel like they're favoriting anyone. But I think it makes sense. I think so. Shifting over, I think that again, the big thing that like interested me from you is like your background in like building data infrastructure. Some of it open source, some of it internally at companies. So I guess I'm curious, like, how did you kind of start? Maybe first, like, just on the open source side of things, how did you kind of start building, or getting involved in those projects?
That actually came from Cloudera, because we had very close partnership with the open source community. A lot of my colleagues were committers, PMC members into those projects, and sort of these rock stars that you like actually build those things from the ground up. And it was inspiring to see that, personally speaking. So I wanted to dive in myself and learn a bit and sort of contribute there. But the sheer spread of that is daunting at times. Like, you had Spark, which is a very sort of busy community. So was Hadoop back then. And so trying to find your footing, trying to find like what code or documentation or something to contribute, that's where the challenge lies, I think. But I see there's a lot of value in doing that. So if you're looking to jump into open source, I think you would definitely get value from just doing APR. Like, I would say, like you have your own perceptions and assumptions that you can do internally, because, oh, we write code this way. But then when you go into the open source world, there are different standards and different sort of norms that you have to adjust to. And so you get like random reviews, you get nitpicks, you get all over the place kind of feedback. That is really helpful, actually, like to make sure that you are that well-rounded engineer. And I learned a lot from that experience. So like going to Spark, I even tried like Beam, Flink a bit, and most recently was Iceberg. I did some patches in Hive and Spark as well. So, and the open source things helped me in my job at Stitch Fix, which was sort of maintaining these open source repos. So I used to maintain the repos for Spark, Hive, and Iceberg. And so if it needed patches, if it needed to build binaries, all of that was sort of under my purview. And so I learned a lot from just like maintaining those as well, and then making sure we're updating those, patching those, bringing them correctly, building them correctly. And there's some lessons I learned from like moving Spark from 2.4 to 3.1. So all of those particular pieces kind of helped like in my learning along the way, and sort of diving deeper into open source. I do less of that recently. Like since I joined DBT, I did like a couple of things in Spark, and I'm trying to do one other thing. But most of my work is mostly internal, so it'll take some time to go back into open source, I think, for me.
Yeah. Yeah. What was the thing? Were there any learnings from going from 2.4 to 3.1?
Oh,
I mean, gotchas.
I mean, that was kind of a migration that they went from like, because there's two aspects to it. One was Scala 2.11 to 2.12, which was sort of a big move. And in general, I think Hadoop as well changed. And so in our libraries that we had to not just build the binaries, but rebuild everything internally that depended on Spark. That was like a laundry list of libraries and making sure everything worked. Like if there's breaking changes or something that changed in going from 2.4 to 3.1, and there's a long list of things that changed. So I took like a month to just do all of that correctly, like integration testing. We didn't have one. So we had to set up an integration test suite for Spark to make sure that we cover all our like types of jobs. And so it took a month to get that rolled out, and then making sure people are aware, give them sort of a test version to try it out and tell them like, hey, throw your pipelines at this and see what works. And yeah, I think that it was sort of smoother after that first hurdle of just getting over the hump of the library changes and configurations. And I think after that was almost because it was not that great of a change, or we didn't hit some of the tiny edge cases. We hit a few configuration issues like here and there, some like timestamp conversion and legacy values or something. But other than that, there was nothing majorly breaking. But just that first hurdle, I think, was the larger pain point to get it right and get it working. But I'm glad we did enough testing that supported our initial launch.
Yeah. Migrations. I'm glad that. Well, no, everyone has to deal with them, sadly. Whether you're a data engineer, software engineer, it's like welcome to your like half of your life. Man. But so you've kind of led a few projects, I feel like, at Stitch and probably now at DBT. Like, how do you recommend people kind of get buy-in for building these kind of pieces? Like, what I'd say is probably pretty massive in terms of like infrastructure is going to support, like you said, the data scientists. How do you get buy-in for that level of kind of project?
We had this thing called like informally like an elevator pitch of what we actually propose. So come up with what is this sort of the high level goal we're trying to achieve, what the use cases are, and sort of put it out there to get feedback. So that was one thing back in Stitch Fix. We have something differently inside DBT, which is a bit more formalized, like an RFC process. But in Stitch Fix back then, it was, can you enumerate the use cases that you're trying to solve? Have you taken some time to look at the possible alternative tooling? Like when I was doing iceberg work, I'll give you the example that might tie this together. Like I had to look at Hudi, Delta, and iceberg, sort of in that lens of, okay, what are we solving and how does it help? And it came out that iceberg makes more sense given S3 and Hive and the proximity in that infrastructure that we had. But I took like a couple of weeks and almost 3 weeks, I think, just to evaluate the tooling and say, hey, this is actually solving these cases. And one other thing that helped in my case was, and I think it's sort of recommended to do, is call out uncertainties. There's unknowns that you might not fulfill when you do this. You might say, I don't know how this integrates with X, Y, and Z. I don't know how this works in this other frame of reference. Does it solve every use case? And so that comes from like that other, like going a bit one level deeper and actually playing with that and going and trying with different use cases, setting up like a MVP product and going through that sort of first step of like just proving it out, I would say. Not just like the high level that this technology works, but going in and seeing the pain yourself. Like, does this make sense for what I'm trying to do? And then that uncovers a lot of the uncertainty. So with iceberg, there was a lot of unknowns. Like, I don't know how this fits in this one use case. We table that for the future. So, but when I was leaving, that was still sort of something my colleagues picked up. So that's where it sort of helped. That buy-in processes has to come with like enough conviction. With like, you can say, okay, I'm solving this use case. This is what I've done. This is sort of the research backing it, and that's where you sort of get the comments and the feedback early on that you can address any kind of concerns. And then once things are sort of high level accepted, then I think you can move forward. So I think another way to look at it, don't go for consensus, go for consent.
Mm.
Like consensus might be the harder thing to achieve. Like you can't convince everybody, like, but do it enough that nobody disagrees with you.
Mm.
I think that's a better way to look at it.
Yeah, that makes sense. And I'm glad you called it like calling out uncertainties, because especially when you're doing on a project at that level, yeah, you can't know it all. And you're like, look, as we're building this, there are going to be things we might have to figure out. So I think it's good that you like reference that, because I think most people probably, like you said, like go one level deep, and it's like, this product says it will do X, Y, and it's like, well, every product says it's going to do X, Y, but there's always a problem. There's always going to be problems. It's never perfect. There's always limitations, and if you don't kind of call it out, you're not going to know until later, and then someone's gonna be like, why is it this way? Why doesn't this work? And you're like,
And it's not possible to know everything. I think you'll still hit blind spots. You'll still hit roadblocks in the along your way. You'll say, okay, I didn't even think about this. Like that happened to me a few times. Like, how do you? I think I can't remember the particular case, but it was unknown. Like it was literally something I did not think about, and I had to pivot and spend a couple of weeks into there. And but yeah, that sort of helps clear out the what you don't know as well, so that people are aware. Okay, this is not thought through. This is not fully fledged. So I think I can agree to it at some point in time.
Yeah, it sounds like you're saying also create some sort of design doc or something
Mm-hmm.
as well.
Could,
It's like, well, I mean, I guess that's just one way you can like call it, I assume, uncertainties, but just something like that. But yeah.
I think that comes a stage after that. Like at least once you get that buy-in,
Okay.
Like I wouldn't jump into design until like it's sort of agreed on, because if you jump into that step, then people come back and say, oh wait, why didn't you just tell us about like whatever? I mean, it works differently in different orgs, but I think the right way to do it is get that sort of initial cohort to agree with you and like pull out all the concerns so that you're aware, and then go ahead and build it. Then I think that makes it a bit more easier to put it out there and say, hey, this is the plan based on what we just did.
Yeah, makes sense. Do you still have a preference in terms of like Iceberg, Hootie, and Delta at this point, or?
When people ask me this, like I'm like, no, I don't recommend any particular tooling unless it's like use case driven. Like you have to think about what it means to you and your org, because what kind of problem you solve might differ in terms of the solution that you pick. So I think it's best on people who are solving the problem to understand if one versus the other makes sense, rather than saying, oh, I like this because somebody else is using it. It might not map one-to-one with every org. So I think find out that use case, make sure what works best. There might be sort of a place where you like one or the other, and then you look at like trade-offs and like actual technical detail, like does this perform better, efficiency, those kinds of things. So you go, that first level is just like, okay, this is makes sense for the use case that I'm trying, then process of elimination, and then you go a level deeper and understand the more techie side of it, I would say.
Yeah, but I read an article, so no, I'm kidding. It said it was going to solve all my problems. So
there we go.
Do you have any personal favorite projects that you've kind of built out? I'm just curious.
Oh, I liked a lot of the work I did on the metadata side of things. That was I can talk at length about that if you want, but like the work we did establishing the metadata ecosystem was really challenging and just like taught me a lot. So that's where my sort of heart lies, I think, over the past 5 years. That's the one thing I remember.
Yeah, and I assume you mean like data catalogs, or?
So this was mostly, and I can go into detail. Sure. If that's okay. All right. Yeah, okay. So the backdrop to this was like we moved to Spark. This was pre me arriving at Citrix. It was like we came into Spark, but there was metadata that was not structured, and so the Hive Metastore seemed like the perfect candidate, and it is. Like it's like sort of fits well in the Presto and Spark world, providing metadata. And so metadata here is just like structured entities that have pointed to a data location. So as simple as that, like with columnar and like schema information and other fields if you want to enumerate. And so the Hive Metastore, for what it's worth, is still a decent amount of tooling. But what it takes is the ecosystem around it to build and take advantage of. Like, how do you build it to scale? How do you make sure all tools integrate with it? How do you solve the business use cases that you have? How do you make it surface to the users? All those kinds of problems are what we ended up solving with like a REST layer that sort of made it ubiquitous for people to interact with metadata, proxy layer that sort of took all the traffic and added like some configuration values that could prevent some damage and like some business use cases to solve. And way down below is the actual like sort of hosted standalone meta store that took all the brunt of it and was the source of truth. And so that I think was like, if you stared enough at a thrift file that is 24,000 lines long, then you get scarred for life, I would say. And so that was one of the lessons when I was solving a thrift specific problem. It was a teachable moment in general, but it was fun, like, because not just the infrastructure scaling part of it, but in general, when you think about the user experience and how people use the software, then you develop somewhat of a level of an empathy that you can actually tie back to building the product that you build. Yeah. And so we learned a lot of lessons, like how comfortable can we make people use metadata, and then added additional pieces that can be tied to like, oh, I can add like comments, I can add specific attributes that are team specific and make sure those got surfaced in the dashboard, those kind of things. So all the auxiliary stuff came after that sort of base infrastructure, but getting that rolled out also was part of that challenge.
Yeah. What was I just thinking there? Oh, first I was going to say, like, I don't remember, maybe you posted it, but I remember reading somewhere where someone referenced like the Hive Metastore. It's like, we've kind of gotten rid of almost everything else Hive-wise, but like the Hive Metastore, it's like, yeah, we're keeping this for like everything. And you're like, what? so I don't remember where I saw that, but I thought that was interesting, just that reference. It's like, yeah, it's good for a lot of things and we're going to keep using it. So that'll be interesting to see if that's like still around in the next few years. In terms of like data infrastructure, are there projects that really kind of excite you kind of going forward, that you've either seen or see people are building and you're like, yeah, this project looks like, kind of the next thing trying to solve a very complex problem?
I've started actually poking around DuckDB and modal. DuckDB is more like OLAP, kind of in memory. I just literally started playing around with it yesterday. I was reading stuff, but I just didn't go in and do stuff into it. But in-memory database, and then I'm trying to see how that scales and see how that works. Sort of my own curiosity there. Excited where that space is going. And the other thing I just got a early preview of it and got invited to it was Modal, which is sort of the execution framework, trying to run things on the cloud natively from like Python code. So that's exciting as well. I'm going to explore that a bit. I just got access yesterday, so I was playing around with some examples. And yeah, I'm curious where those things are headed. Like those are sort of random things. They're not exactly related, but I'm kind of excited where their trajectory is.
Yeah, I was gonna say, I think DuckDB keeps coming up over and over again. Everyone's like I think it feels like there's definitely maybe not everyone, but at least a good sized group of people are very excited for it and what it's possibly allowing people to do. So now it makes sense. I've never heard of Modal, so now I was like typing it in. I'm like, I'm gonna have to look this up. I have no idea what this is. Welcome to the data world where we're just constantly trying to solve the next problem. Is there a problem you think that, like, I don't know, maybe some data infrastructure isn't currently around to solve that needs to be solved? Or
I was exploring a little bit of the metadata side of things. Like I think you mentioned Hive Metastore earlier and how it's still around. I think maybe some work there, like not exactly like a data catalog, but actually you could build a data catalog technically with that information, but solving like discoverability and governance and things like that. So I think folks like Metaphor and Atlan, those guys are solving that particular aspect of it. But I was thinking, just curiously, like, could I do that with the Metastore and just like spin up something to test that? Maybe that might help, given the already established patterns we have with Hive and how it connects with the rest of the world. I think maybe we could take advantage of that and build something out of there. But this is still in my mind, so I haven't explored that thought beyond this.
Yeah. Well, who has time? Who has time to
I know.
explore anything? like that's like I don't know. I feel like I spend whatever 80% of my time doing work, 10% of my time, if I'm lucky, getting to poke at things, and I never get to go as deep as I want into anything. It's just like, okay, that's interesting. If I see it in production, I guess I'll learn it, but I haven't seen it in production, so I guess I'll
Yeah,
just pass
I'm
on.
sort of I was sort of hesitant about looking at like even DuckDB, like because the documentation kind of made sense, but a level deeper, like where does this actually fit? How does it scale? There's companies that are trying to solve that problem. So somebody asked this question, explain DuckDB like I'm five, and that had a lot of information in there that sort of even cleared it up for me.
Mm.
And yeah, we'll see. We'll see how it goes. There's umpteen problems to solve. I think people are just coming at it differently with different tooling, and yeah, so I'm just hoping to see like I'm worried about the user, the user
Yes.
and the maintainer who's actually like gonna like use this and actually work with this. So if it solves their problem, then yeah, it's a good solution. I think
Yeah.
no need to complicate that.
Do you have any like tips for people, I guess, building data infrastructure? Because you say user, and like in general, a lot of users, especially of data infrastructure, tend to be somewhat technical, or maybe even like technical. So like, how do you build something that's like really a good medium where it's like this is both technical enough, like it's not too technical where you've got to go like go real deep, but it's also not drag and drop because there's something, especially if you're engineering techie, you're like drag and drop. Yeah, how do you like kind of find that balance that's the right solution?
The sort of personas of user, I would say, to look at when you consider building something. Like who are you building it for? Like how are you surfacing the
Mm,
information that you want? Like are these users very sort of in the technical spectrum? Are they very tech savvy? They can sort of run with what you build as a sort of foundation, or on the other side, like okay, you can provide the insights to them directly, and they can just use it to whatever like business use case they want. Like let's say you're surfacing financial dashboards to folks in finance, they might just ingest it and use it in their process internally, and they don't have to write any code or actually be part of that analysis. So I think thinking about who you're solving for, which persona, that
mm,
might help you design better, because uh, based on how they interact will sort of reflect on what tooling you build. Like, because is it going to be a dashboard? Is it going to be an ETL framework? Is it going to be just um, like I'm going to give you a SQL tool over some data and go crazy? So it's kind of a mix of all of that based on who you're surfacing it for. So let me give you an example of like what we did. We wanted ad hoc queries to work, like just for read patterns. So and we had the data warehouse in S3. This was back in Stitch Fix, and so Presto seemed like the right candidate for that because it was in there. It had all the bells and whistles that you need. I think the challenge just came from scaling it and implementation, but otherwise, it was a decent interface that people could use and run queries ad hoc. That was not part of production, but just like read only. And so that kind of solved it for at least the business use cases. And you don't have to go to like Spark, and it's easily like familiar in terms of SQL, and so you could just hit and just get the result back from that particular interface. And so that kind of solved it for like even data scientists would employ it. It would power uh, like our metadata dashboard, which extracted like sample queries on Presto. So
mm.
it had this sort of dual effect, but the intention came from, can we provide an interface that people can just like throw queries at to be simplistic enough?
Yeah, yeah. Since you referenced Presto, did you guys have to do anything for security? Or how'd you? I'm just curious. And maybe you didn't. Maybe you weren't on that team, but I'm just curious.
I didn't directly own it. I like played around with it a bit. Like one of my colleagues was a bit more the owner of it, if you will. Um, we did have some access control lists going on and sort of had different deployments based on who we wanted to surface what data. So I think that's sort of the level of not exactly security, but like bifurcation of like how we divide the access. That's where that came from. So ACLs helped in that. Other than that, I think we just wanted the pace of it, like the actual like interface and the actual like speed of the query, so that we can
Mm,
take advantage of the source of truth that we have and just throw a SQL layer over it to be easy. And we built like client layer, and then we had it plug in automatically. So those kinds of things came after that. But
yeah, I think it's interesting to me in the database space, because we've literally gone from like there's whatever one company makes database. Now then it was like, okay, one company makes database, but they separate storage and compute. Now it's like you can literally piecemeal a database together with like Presto, Imuda, like something to do security, something to do like indexing, something to do storage. And so it's very interesting how you can basically like just piece together your own database from like 5 different companies. And so I'm curious how that's going to all play out, like if that's beneficial or if it's going to be chaotic, or
and that's where the maintainer piece comes from. Like I mentioned, user and maintainer, like whoever's going to build this infrastructure has to go around, not just like, hey, we built it, this is the use case, but long-term maintenance, like monitoring, alerting, and like sort of identifying how to upgrade it, feature building, those kinds of things have to come as part of that puzzle. So it's on top of the maintainers to go and be the judges of it and how they actually execute. So I think that's where they have to decide whether this makes sense for them, or can we just, it's kind of like a build versus buy at the end of the day. Like can we do that or build it ourselves?
Yeah. And I do you have any, like, with the build versus buy, any specific thoughts there? Like just like more like vast generalizations. Do you have like a hard fast rule, like here's where build makes most sense, here's where buy makes most sense for people?
There's no generic rule, but I'll give my 2 cents. Like when we were in this in Citrix, it's mostly like build versus buy was mostly build because of problems like cost and integration, and sort of we were a tiny team. So like I'll give you this like very weird thought. Like this was back in 2018, I was talking to Ryan from Netflix, who was building Iceberg there, and he was proposing this, and I saw this initial design doc, and it sounded promising, but we didn't have the resources to actually incorporate that. And so we had the meta store, it was janky, just getting that to stable state was one of our priorities. And so we sort of punted on that, and we didn't do it. It kind of, I don't know if it had made sense back then when it was sort of tinier, but we sort of waited. And then in this case, in other cases, like we relied on infrastructure from AWS, like can we use like Athena or something for some use case so it all depends on what you're trying to solve. And the build versus buy argument comes when you're looking at cost, you're looking at integration amount, you're looking at that trade-off of like spending resources for the benefit they get. And then it's sort of not exactly contrary to that, but the vendor argument is like, will I get locked in? Will I get feature parity at some point of time?
Yeah.
Will bug fixes be prioritized? Those kinds of things. And we saw, I know this from firsthand from my Cloudera, because people used to ask, like if Spark released yesterday, they used to ask us, hey, when is it coming in Cloudera? I'm like, wait, it just came out yesterday. So give us a month to vet it and test it. So that like AWS doesn't do it. Like Spark lags behind their EMR release because they have to vet like 15 products and make sure everything is coherent. So I think that's where then that comes to where you want it to be. And so I don't know if there's a healthy medium between build versus buy. I think that's for the people to figure out. You can go all in on one or the other side, but the after effects of whatever your organization might feel, and then you can just pivot the other way, or just like let it be for technical debt reasons.
Yes. Yeah, I think with AWS, they're always, I think on most things, I know it's like Airflow and NWAA is always a few 2 or 3 versions behind, and then Astronomer's on point because they're obviously helping maintain Airflow. So, yeah. Also, the build versus buy movie thing. I think I saw a tweet about someone who's like, maybe did you like this? But like someone posted about like how much money they saved for like running GPUs like locally versus like they set it up somehow on prem, and they're like, yeah, it cost us $200 a month to do on prem. It would have cost us $2,000 a month to do on AWS. Which I don't know how much like manual effort went into it as well. So obviously, what's the total cost? I don't know, but it's still kind of like sometimes it might actually end up being cheaper. So it'll be funny to see like if we figure out more about that in the future.
Yeah, on-prem is an old word for me. Like Cloudera had a lot of customers on-prem, and it was interesting to see them like, because cloud was there, but like AWS was sort of buzzing, but
Yeah.
they didn't build a product enough that the customers could take advantage of. I don't know if they have right now, but on-prem was the big thing. Like people had their own like machines that they could control and like have more focused spending, I would say.
Yeah, it's crazy to think that like people were managing all of that on-prem, and nowadays it's just like, oh yeah, I spun up something myself, like EMR, it's set up, it's done, versus like I had to buy a ton of servers. Then we spent like a month trying to figure out how to make it work. We got it to work. Now we're like, it's such a different world. And I think I was thinking about that today. I was like, it's
my
so
experience
much different.
in EMR. Sorry, my experience in EMR is that like I've even bidding for spot instances to that extent. Like, okay, what is the right price to bid for this so that we get it reliably, so our Spark jobs don't tank. So we have to do that. So I had to do that calculation with one of my VPs. He's like, yeah, let's do this thing is spiking. Let's just do this. I'm like, okay, what is the best price for this? Oh, let's just set it to on demand. We'll see what we get, because we pay lower, and then reservations of AWS instances, those kinds of things come in play, and sort of cut cost. Sorry to interrupt.
No, you didn't. I think it was a valid question. I think there's a few questions in the chat, so I'll bring some up.
Oh, cool.
One that's a little more technical, so you might enjoy this. So, have you needed to do any high availability with Presto Trino running into a problem now with our coordinator being overloaded? Thinking about using Lyft's Presto Gateway to manage multiple clusters. He's looking for free consult. No, no.
I don't think I've encountered it. The most problem that we had was sort of resource allocation in Presto and Trino. We didn't have that much scale, I think, to run HA in this context, but I'm sure there's tooling. I don't know what Lyft's Presto Gateway does, but I'm assuming it does like some sort of snapshot cluster or some HA like syncing stuff. Like you go back to like basics of HA. But I didn't encounter this, to be honest. Like with respect to Presto and Trino, it ended up mostly being resource heavy and just like falling over sometimes with like one or the other queries stalling, and so we had a lot of resourcing problems. But one of my colleagues went in and tuned some of the instances and made sure that was correct. And then I think then we moved to Trino eventually. Like when I was leaving, we were experimenting and moved over to Trino, because Iceberg was there. It had the connector. Not to say that Presto DB does not, but I think Trino made sense to us back then. And so I think they're fairly on Trino. I can poke around, but yeah, sorry, I haven't touched this aspect of Presto and Trino, but I'm sure there's solutions, and I don't know how manually painful that would be to establish. Like we came from a world from where we depended on Amazon's Presto, and I'm sure they had some sort of multi-cluster, multi-master setup that would give HA. But doing this in person, we didn't find the need to do that, to be honest. So we had like a bunch of workloads and master nodes to spread the load, I would say. And those instances, I think you have to sort of figure out the cost, I think.
Yeah. Not another question, but just more kind of continued response is, the biggest downside of Presto Trino is the single point of failure with the coordinator. Everything else is awesome. Thank you, Dan, for the question. All right, so this one, how does, and I think this is probably relevant, how does one identify which open source projects to contribute to? And given an open source project is contributing, finding bugs or adding innovations to the existing project? I don't know what that second part actually was asking, but the first part I think is easier.
I think you can go after the more popular ones, but I'll tell you, you'll hit a lot of complications and a lot of like competition in general. Like there's a lot of people vying for that, not exactly attention, but like trying to be a part of that cohort of the new folks who jump in. So I think it depends on what's more close to your daily work or something that interests you. I think the first step to look at, like you can jump to a larger, more mature product like Spark or Kafka or something like that, but I don't know how much value you will give. So if your goal is to just be a contributor, then you can pick anything under the sun, but it depends on what goals you have based on what you're trying to achieve. And if it's like tied to your work, then it's even better to engage into one of those communities. Like why I did Iceberg was because I wanted to understand the code that would help me at work specifically. And so I did a PR on the JDBC catalog, which I thought we'll end up using. We didn't end up using it, but it still taught me enough that I had context to do my daily work. And then contributing itself not necessarily means finding bugs. Like when you start, you'll have like typically decent enough projects who are maintained have like good first issues as a label in the PRs, sorry, in the issues. So you could pick up one of those and just get yourself familiar with the code first of all, or even like sync up with somebody as part of who's like a PMC or a committer, just to get an understanding of like what the project does and the nitty gritty of it. Because a lot of the nuances come from the tooling, the way they build, and like testing principles and building guides and like workflows. So those kind of nuances is something that you might not achieve by just staring at the code for long. So you can start small, start with like the first good issue, and then go with bugs as long as you get more context and try to solve like tiny priority items. And then that's how you build sort of that expertise. And then don't go for a big bang innovation that you might not be able to achieve that without a lot of context. Like you can do it technically speaking, but you may miss a lot of gaps that you will see in the review if you try to attempt. So I say start where you are in the beginning of the project, and then find bugs, adding innovation, even documentation actually it doesn't get said a lot. Like that's also valuable contribution, to be honest. Like making docs clearer is really a boon to the project. So I would say pick your poison, like go crazy on like the first, but just start slow for it to be very just.
Yeah, that makes sense. And it's I never thought about the whole like, yeah, popular project, you're probably going to get ignored or someone else is going to fix the bug, or yeah, it's probably a lot harder to get involved. Also, what's great now is there are a lot of open source projects that kind of have a like, business end. And I mean, it's always kind of been that way. I think MySQL even had that, but even more so, I feel like today. So it's like, oh, you want to contribute to Trino? Try to join Starburst. Then it's your job. So at least you get paid for it. So yeah, there's definitely a lot of interesting ways. Let's see, where's this next question? Oh, so this one, let's see. I don't know if since you're not directly a DE, but just curious, what's your advice on how best data engineers can be more FinOps aware when working with different tools, architecture, layouts?
Sorry, what is FinOps? Financial operations? Or?
Yeah, so FinOps is generally like tied to cloud costs. So yeah, like it's more usually, or at least it was referenced more, I think like a year or two ago, towards purely like AWS like services in general. And then I think recently in the last 2 years, like with the proliferation of like Snowflake and gaining popularity and things of that nature, it even more is focused there, where it's like, yeah, how much does this pipeline cost? Oh my gosh, it's costing us $1,000 a month or something. So there's that.
Oh, that's helpful. Thank you for that context, because that's a harder problem to solve, and I think that's chargeback based on understanding how much your pipeline or anything costs. Like we had, like I could stare at the cost explorer in Amazon and not tell you where any of this lies, because if you lack like metadata, and if you lack a lot of that infrastructure that tells you that the traceability aspect of like where a pipeline lies, what metrics it ran, I think that's where you actually get a little bit more awareness of the financials of what you're building, because in the absence of those metrics, you're not getting sort of CPU hours, you're not getting the instances that are used, the time that it's taken to execute, the cores that were used per cycle. So I think having that layer is important, and then tying back to the infrastructure, either with metadata or some other like service layer. Like to be honest, there's no like consistent way I can think of like how to describe that, but like if you have some layer that sort of obfuscates and like even traceback and distributed tracing might help there to understand like time, but doing that at scale of like Spark and other like Airflow orchestration stuff, that can be tricky. So there might be tooling that is built to extract those metrics, and I don't know how that directly translates to cost, because there's different size of instances. You could guard those level. You could actually specify, oh, I'm only using M5 large or some other type, so you know that okay, my executors are only using this particular instance type. So that cost is relatively fixed, depending on, there's more nuances like on demand and spot pricing and stuff. So that I think it gets to a very gnarly detail if you go down it, but I think to be aware, from what Samuel's question indicated, was just to be aware of like how you can measure this, like focus on the metrics of what you're actually doing. So the pipeline that you execute emits enough information that you can make a deterministic call of what that price that you pay for that, and not just the pipeline, but if you can extend it even further. I think the higher level is easier to do, and then drilling down to pipeline level might be the hardest. So I think start where you can trace, like, okay, how much does this cluster cost for 10 days or whatever, and then go on, like, okay, can I augment my pipelines to give enough information?
Yeah, I think that makes sense. Like, if start high, go low. If you can, the more you can drill in, the better, obviously. But if you can at least know, like, okay, well, this is the data warehouse it's coming from, or whatever you're using, or this is the Spark cluster it's coming from, and then from there, hopefully, like you said, you can start breaking down, like, okay, this is the jobs. But yeah, it's just always really hard with cloud, because it's always just like a derivative. Like with Snowflake, it's like a derivative of a derivative, right? Like, okay, we're taking AWS costs and then putting on top of that Snowflake cost, which is in this weird credits concept. Okay.
Right.
So yeah, there was a lot of people that put a lot of effort into like trying to figure out, like, even at Facebook, like, how much compute did something take, right? Because like, and even that, like, there was like, I don't know what our definition of compute was, because that was like not even like consistent. Sometimes it's like, oh, this means whatever it was, compute hours per something or whatever, and it's hard. It's weird how like hard it is to like drill down to exactly what something took. But I know a lot of companies are trying, like, again, like even like Facebook and Amazon, I know both have their own systems to kind of calculate how much things are costing, calculate how much a table costs. But it's all a guess. Best, especially internally.
Yeah, because elasticity comes at a price, right? You get that flexibility of auto scaling, you get those like automatic scheduling and everything, but then there's a price to pay at the end of the day. Like, okay, how much am I paying for this flexibility? And I think that's been sort of the deterrent for people who go to cloud. I think, like, okay, I don't have the idea of the costs that I'm going to end up spending, so maybe a tighter budget team would be apprehensive of it. So I think that's where some of the hesitation might come from, I think.
Yeah, I think that's, once what I've noticed, most of my clients tend to be SMB or mid market, and because as you go up, like a CFO or a director of finance is just like, just tell me what this is going to cost per year. That's all I want, and that I can do, right? Like that I can like calculate, like, okay, that's going to be whatever, and I'm cool with that. They're not cool with the this month it was $1 million, next month it's $500,000, and they're like, how do you not know? Like, you can't predict this. And it's like, so yeah.
And then suddenly you see like a C9X being used in your AWS Explorer, like, who the hell did that? And so it's like, wait, what pipeline did that? And then you go and hunting in Slack, and hey, who ran this job? And so that kind of chase begins after the fact.
Yeah, at Facebook, it was always a machine learning engineer. It was like, who's, because we did, like, we just had like a thing that would detect if you were going over your average compute, and then like it would just like every day kind of just let you go up a certain amount. But every once in a while it would like double, and you go, oh look, there's like some machine learning engineer running something, and it's like completely blown up our namespace's compute. We had plenty, but it was just like, hey, what just happened? Can you turn this off? Okay, so this, and I know like you referenced, like, since you just started DBT, so if you don't have a good answer, that's fine. So I use GitHub Actions for deployment and versioning of BigQuery tables via scheduled queries. What could DBT do better? Never used DBT before. Pretty hard to understand the use cases.
I'll sort of give the spiel I know. Like, I played around with the product as part of like when we start, we get an introduction to the product, and then we get to play around with it. What DBT does is essentially, there's this whole persona of analytics engineer, so empowering them with already familiar tooling like SQL, but adding a layer of like, okay, we have GitHub project style workflow, so you can actually collaborate with the teams, and the execution is actually done on the platforms themselves, so like Snowflake and BigQuery and Redshift. And so you're worried about this, the actual references, the SQL, and so there's Ginger templating that helps you reference particular things. So there's a lot of you think of it like a software project, and so that's kind of neat. And then you can actually use it that way and collaborate within your team. And so SQL is the sort of familiar ground there. And we're venturing now into Python. That sort of came out recently. I haven't paid attention to the like when it came out, but I know that's what's the next in line for support. So we can actually tie in those use cases as well and collaborate with like Snowflake, and Databricks, and the other sort of platforms that can execute this for folks who are using those kind of data platforms for their data. And that's where I think the value lies, but essentially to get transformations and to get that, we provide that lineage for you so that you know where's your source table, what did you derive from it. And there's another aspect of metrics that's going to come up. We're going to announce it towards the Coalesce timeframe, which is our conference. And so that's a different aspect to this. But to give you an answer about like deployment and versioning, there is some level of versioning because this is like so very tied to a Git provider. So there's versioning implicitly. With tables, views, scheduled queries, I'm not sure like how that like sort of versioning applies to like queries itself, but like maybe table schemas, I think that might be prudent. Like if you want to broadcast some changes, I think that might be where this person is coming from. So that's, I think, a different thing. But my spiel is the DBT unlocking was the transformation and the actual like SQL interface and using it for analytics engineering.
Yeah, and I would say that like I was talking, I don't remember which conversation it was that I was having with several people. I think it was like a few where I was talking about Airflow and a few that I was talking about like pipelines. A lot of people will reference that, like, you know, they have either worked at companies that have developed something similar or, you know, various things of that nature. So I think there was, you know, that people can always come up with different ways of kind of how you run scheduled queries, because that's really a lot of what it is, right? If you were in the Microsoft shop world, you know, a decade ago, you used SQL Server Agent to run, you know, everything from stored procedures to SSIS jobs, and most of that was like SQL and, you know, just running at certain times. And so I've definitely heard of a lot of companies making similar things. And so DBT just made something that was standard. And I think it's like Airflow. Airflow is the same thing. Like if you read Maxime's post about Airflow, he's like, you know, prior to this, everyone was building an orchestrator, right? Like everyone built orchestrators, and people still do. But so he looked around and tried to figure out like what was the most robust way to build it, and he built it, and you know, then standardized it, and it got popular. And you know, now we're, I think, 6-7 years later, and you know, we have other options now. But like that's kind of the interesting story, or not interesting, but like that we are all commonly trying to solve similar problems, and so it's just the person that finally builds it either to big enough scope or marketing or whatever, and suddenly something sticks. So yeah, you could obviously do scheduled queries in a few dozen other ways. But
yeah,
and obviously you guys, DBT does more than scheduled queries. I should be kinder to that.
No, I'm trying to think like with orchestration, like, because I came from a world like Uzi was there back when, and then there was can't remember what else. Like I had to like hack kind of like a Spark orchestration workflow for doing something specific. This is pre-Airflow and Stitch Fix, but Airflow was like a big boon because we had this whole DAG notion, we had tasks, and we had a little bit of telemetry from there. So that was really a blessing coming to the team. A sister team actually maintained that, so that was not entirely us, but we sort of provided that Spark layer, making sure those like templates were sound so that Spark jobs could run in these machines. And then underlying, there was a whole execution infrastructure that would actually run things in a containerized mode. But a lot of that infrastructure was really helpful to have to achieve this. But Airflow itself, I'm like reading stuff like people are not seeing it like fulfilled present day. But I've seen a world where there was no Airflow, so I think we're coming a long way from that sort of darkness, I say. And now we're like, okay, it doesn't fit all of these things. Sure, it might adapt. I don't know what astronomers planning, but I think they're more like a control plane over Airflow. And so I think maybe that's the way to go. I don't know, but interesting. There's Dagster, there's Prefect. I think Prefect, yeah.
Yeah, no, it's Prefect. I think Preset,
Oh,
which is Maxime's new company.
that is,
Which is
yeah.
so it's just like, gosh darn it, stop building things and start name them differently. But yeah. For a while there, I actually used to get those confused. I'm like, wait, what? And I think the first few times I read it perfect. My brain just was just like, perfect. Okay, that's the interesting name. And eventually I was like, no, the R is in a different spot. But that's funny. Okay. This is just funny because this was referenced to our earlier part of the conversation. There's no question here. Just
Yeah.
all of us wondering where our AWS bills go. Because like, I don't know. Like I honestly occasionally, like I'll just have an EC2 instance spinning and running every once in a while. And I'm always surprised at how much it actually ends up costing. Like I just had like a small EC2 instance running. And it still cost me like $50, and I think it uses the free tier for the first like 30 or 20 days. How is this so expensive? So yeah, I totally get that. That's honestly why I've sometimes even moved some clients away from things like MWAA or Cloud Composer, because those things are always running, and so it's like a minimum of like $600 to $1,000 with nothing, and it can have nothing on it. It could just be sitting there, and it's just constantly like pinging. Like, do I have any jobs to run? Do I have any jobs to run?
Yeah.
Let's see. So this one, let's see. So, I mean,
Ooh.
any takes here?
Oh God. Okay.
You don't have to answer. I could also just like give a quick.
No. I'll take a stab at it.
Okay.
I think it's gonna adopted widely by companies. It's just gonna fizzle out soon. I came from the sort of old data stack, or there was a data stack back then. It's like I don't know, grandfathered in. But I think what the modern data stack does is, in general, like gives them more choices in general to the people that are trying to solve different use cases, and that sort of burst of tools that came given this movement, and then you now have set tooling that sort of fixates itself into different areas. That kind of helps standardize it in some way. I don't know how to think about it. To be honest, I've not yet formed an opinion. Like I have chats with like Tristan and like trying to see where his head is at and see where this is going. But when I was at Databricks, the Data AI conference, I saw that shift happening. At least not just my mindset, but like in general, like when DBT was placed right there, it was kind of a force to reckon with in terms of like Matillion was there, there's Fivetran, there's other like sort of players in that space. Atlan was on this other side. And sort of you saw these users who came from like Spark world, and I kind of relate to that because I came from that world, and sort of them seeing how they fit into this world, and how what the use cases they have can be solved by tooling that is currently present in this modern data stack. Somebody says it's dead, somebody says it's going to fizzle out. I don't know. I can't predict these things. Like it's kind of like, if it solves, like my take is like, if it solves the problems that you need, I think a standard can stay. But like somebody asked me, what does HDFS look like in this? And I don't know. S3, I don't know. Because it's like, again, use case driven. Like it's like whether it solves your problem.
Yeah.
And there's a whole argument that I'm currently having on LinkedIn about like data storage. Like, why do we have these 10 names? And so like if you want something to standardize, let's just start by, I'm diverging, but like I think it's like, it's good that this is happening. It's like we might converge to a point where it standardizes, but we'll see. Like it's sort of, I think it's early, maybe a few years old, but we'll see where it goes. No opinions at the moment.
Yeah, but I think your storage is a valid point, because it's almost part of it, right? Like in a weird way, it is part of. You can put it part of the modern data stack. You can not, but it's fitting in the similar space where it's like, whether it's because, I mean, partially because of funding, partially because of like data is becoming this beast that you're trying to manage, and everyone has a solution for it. We need a VHS, right? Like, Betamax versus V8. We just want, like, pick one, please. Just like, so we can all, or be interoperable perfectly between each other, like, which is a far, harder ask. I also like, I feel like I've noticed that, like, it sometimes is also company size driven. Like, as you go up in enterprise, you see less what people would call the modern data stack tools. You see more enterprise tools like Azure Data Factory or things like that. And then the more you go downstream, I think is where you see things that are like modern data stacky. So I think there's also just the size dependency because of, again, like how it's going to be billed, right? Like, oh, it's consumption based. Well, a lot of large companies don't always like that unless they have some control over it. And just I don't know if sometimes I don't know if it scales as well. It might, but I think I haven't seen it in a scaled environment. So I think that's it. And then also there's the aspect of like it's just a name. Like to me, it's just like, I mean, like I guess it like is good for like categorization, but like you said earlier, just use what works for your problem. If we're gonna go all to streaming someday and Fivetran's gonna disappear because everything's just gonna be a stream, and sure, okay, that's the world we'll be in, and we'll deal with it when we get there. But I imagine that's 5 years out, 10 years out from now, because first we need to all decide that there's a good solution, which we'll slowly do over the next few years, and then we all have to migrate everything. So for the next few years, people are going to be on this because, again, migrations are a pain, and no one wants to do it until you have to do it. So it'll find its place.
I have stories of migration as well. Like this, it's just another topic to go over.
Yeah, I mean, like I'm sure there's like consulting companies that's all they do, because it's like it's just so chaotic and there's so many ways it will go wrong, right? Like copying data, like making like if you at least back in, I don't know about these days, but like databases, if you're migrating, did you keep the same primary keys and did you make sure it's all perfect? Because otherwise you're going to lose where it's attached to or something like that. There's just so many ways little things can go wrong when you're building and migrating. Yeah. So.
And then backfilling and making sure all that is clean, cutting off, synchronization, all of that stuff is part of that puzzle. And it's not an easy problem to solve, along with like, oh, you have expected SLAs with your clients and teams, and like, can you provide that high availability while you're doing this migration? What kind of downtime you're going to see? And so all of those concerns, I think, come to light when you're sort of thinking about this in a bit more actually execution part. Like I think I saw one decent talk about migration from Will Larson, who used to run things at Stripe in engineering. He mentioned a lot of that problem comes from like, how do you set up the tooling? How do you set up the path for people to execute? And so yeah, that's where the pain comes from.
Yeah, and then there's always like some tools that kind of can do like 70% of the work, but it's all the easy 70% of the work. So you're like, okay, thanks. I still have to do all the hard stuff. I could have made a script that did what you did too, but yeah, I haven't had to do one, I think, in a year or two, so that's actually been nice. But I'm sure I'll find one. It's inevitable because I don't know. Everyone just wants something different, or sometimes there is a better option. Sometimes they think there's a better option, and it's just the way of the world of data.
That's true. Yeah, I think you have to weigh options, like what makes sense, like because it's like there's abundance of tooling, like even databases, there's like a ton of them, like so, but do it make sense, I guess. Like that's pretty much where you should. Like I read yesterday when a former colleague of mine, he's like, this would be cool to build. So I just read this whole thing. I linked it in the post that I did. And they went through like, okay, this didn't work for us. This didn't work for us. This didn't work for us. And then we've settled in on a Postgres mixture of SQLite thing. I'm like, great. that is a lesson learned. But yeah, it's so whatever makes sense for you. So if you're a large company, if you're a small company, I think at the end of the day, how you're serving your users, if it's providing the value that you need for the business, I think the tool sort of matters less, I think.
Yeah, and the thing is, like, you can make a lot of tools work. I mean, Facebook is built on PHP and MySQL. Oh, yeah. So I mean, I'm just saying, like this is meant, like if your tool can't perform, I mean, that stuff's like, I mean, it's not real PHP. It's adulterated. I don't know what to call it. It's called hack. I don't know if you've probably seen it or heard it or read an article about it. But yeah. So, but it's funny just because it's like, yeah, some people just make it work. Some people are like, no, we're just gonna figure this out. We're not migrating. We're just gonna figure out how to do it with what we built it on originally. What Mark built it on his laptop in 2000 whatever. We're gonna keep building it that way forever. So it's just kind of funny.
Yeah, I think people stick to it because of the sort of hard problem that it is, like just getting out of it and just having tooling, getting everybody on board, all of that stuff. So that's one path to do, but there's another aspect to this, like, okay, this other path is better, or for lack of a better word, like it may help solve a lot of problems. Yes, there's sort of that pain that you have to go through. Like I was reading about how Dropbox went through their whole like monolith migration and even their Python migration. It took years for them to do it at their scale, and they had to build a lot of tooling. Like they literally modified gRPC to get them functioning. And so you have to do something that sort of gets you unblocked. And it depends on the size, again, depends on what kind of outcome you're trying to achieve and how many years or like even time you're ready to devote to getting this across, because you see the value. Okay, let's just put our heads together and just say, okay, this is our company's mission. Let's just go forward and do this for our sanity a couple of years later. So essentially.
Yeah, and figure out what you can automate. Like whatever you can automate in that migration, do it, because that's going to save you so much time. Okay, curious here. Do you have any takes on infra as code?
Ooh. How is that? Like, is that
like Terraform or?
Oh, okay, that makes sense. Good for standardization, I would say. Like just make sure those patterns and configurations are maintained. I've never personally played with it. I did a couple of PRs in our Terraform config repo, but another team used to maintain it, and I wouldn't claim to be close to that problem at all. But I think the one nice thing about it is it just makes things a bit more easier, standardized, and a bit more formatted. I think, would we throw Helm charts under that sort of realm as well? Possibly.
Kind of will.
So it's like very like declarative, a notion of declarative resources. Like, okay, it can provision like manifest files of like Kubernetes to sort of fall in that same realm, I think, and sort of be declarative and make sure that you know what you're getting, and it's easy to like change configurations back and forth, and that kind of thing is really useful to have as a team, because deployments are hard. Getting to a nicer place is also like difficult when you launch new products, when you test them. And even in this, like we didn't have this really nicely at Stitch Fix, but like a notion of prod and staging for your benefit. So you can have testing environment, you can have those kinds of, you have that divide so you can test things and make sure that even if it's sanity check, like I used to have a staging environment for one of my services at Stitch Fix for just like running basic integration stuff. And just like, okay, even the tiniest change, I could CI/CD that and just test it in the staging environment and make sure like, okay, everything is great. We're okay. Even if it's a tiny change, yes. If it's like a major change, then you have to do more things. But having that sort of checkbox is really useful. And if you have that configuration, and I think like CI/CD also sort of comes in under this picture, and that's over the years that's been like really helpful to just like automate testing and just make sure everything is right before it goes out. So I value that a lot in terms of this, just productivity, I would say, in terms of when you push out engineering features and like development, I would say.
Yeah, I'm trying to think. Just my brain's now forgetting what I was going to say. Perfect. No, it's just I'm like, yeah, okay, it's lost. That's always fun when you're like, I had a thing and I was like gonna say it and then I forgot what I was gonna say. But I remember. So I was talking to Joe Reese last week. For anyone who doesn't know, he wrote a book called Fundamentals of Data Engineering. But and he referenced, he's like, when you first start doing it, you should do it the hard way, just so you understand how helpful it is. Otherwise, you don't understand why it's helpful. So I do like that. It's like, what, that's fair. Like it's not like it doesn't always make sense, right? Like it's like to some extent, it's like how far is too far back? Like should I rewrite code in assembly to understand how hard and how much I should appreciate, being able to write code in Python? But I think like that one layer back is good, just because you understand why this tool is helpful. It's like, oh, okay, because the other side is, whatever. I think someone put it also as like, it gets rid of the problem. It works on my cloud. It's like, well, it works on my cloud. And it's like, oh, now you can make it work on everyone's cloud, because it should be, essentially setting up everything to the same everything. So it is interesting. And like you said, it lets you do like staging prod a little easier. I mean, Facebook data staging or test in prod did not exist, is what I always tell people. It's like, yeah, there was test underscore table name. It was in the same namespace, but it had test in front of it. So that's how you knew it was test. So you just, I would literally just read out, like if I was ever dropping a table, I would read out the name, because I'm just like, I'm don't want to drop production tables. We could get them back, but I was just like, I don't want to figure it out. Like, I don't want to have to like call and be like, okay, how do I bring this table back that I just dropped? So I was just like, I'd rather not have that day. So.
Oh yeah. And if you have cascading deletes, that's even harder. Like if you delete the underlying data, the recovery is just insane. But one of the things I didn't mention was Docker Compose. Like it's just kind of like, I started recently playing with it. I knew about it for a while, but I just started playing with it recently when I was just testing a few things. And it's just been great, just spinning up anything locally. It's just been awesome. And I could like test things and make sure something works. I was building a prototype for something. It's just useful right there. Like you can just program it and just like, okay, now it works. I don't have any worries. But yeah, it alleviates some of the pain and sanity checking.
Yeah, you haven't run Kubernetes yet on your M1. I don't know if you have an M1, but I have an M1.
I have an M1.
Like, yeah, I think it was like Kind. I ran into issues with running Kind and Confluent, Kafka's managed version, and it was just like, it was not happening. It was like, nope, ARM chip problem, and I was like, what? Are you kidding me? And I think you can go somewhere in the configuration and fix it. And I'm like, I don't want to like risk breaking something like in my new Mac. Like I'm gonna break, like it's gonna be like back in the day when you used to set up Python and you'd be like, where did that actually install? And then suddenly you're like, forget it, I'm getting a new laptop. Because I don't know where I installed this library, and now it's just not working. And if I try reinstalling it, it's like, yeah.
Oh man, in Stitch Fix when we had this, I broke my Python setup like multiple times. I just had to like redo everything. I'm like, no, I messed up virtual environments. I just used to just garble things up, and then I just like made one generic environment and I just use it across projects and just throw everything in there. I don't care. Like it just needs to interpret. That's its only goal. And then sometimes I just use like PyN, which is more simple. But yeah, that's another crazy thing to do. It's just you can go wrong in so many ways.
Yeah. Well, I think questions have kind of slowed down. So I think, one, thank you so much for your time. Thank you so much for sharing everything about data infra, what it's like working in there. Do you have, before we kind of close off, do you have any questions for me or anything?
I'm good. This was really helpful. Like got a lot of good questions. Actually, it was a great time to chat as well. So thanks for having me.
Yeah, thank you for joining, and thank you all for watching. I'm going to hit end broadcast. Thank you all. Bye.